All right, this is your homework that you're supposed to turn into the sub. I'm gonna go through the problems. You can watch, follow along, make sure you understand it all. First problem 12, they want you to connect these dots in all possible ways and figure out how many. So best way might be to label them like A, B, C, and D or something so that you can do it. A, we gotta connect to B, we gotta connect to C, we gotta connect to D, so that's 3. B, we still gotta connect to C, and we still gotta connect it to D, so that's 2 more. And then you still gotta connect C to D, so that's 1 more. So the answer number 12 was 6. Next one, it's got 5. I'm not gonna change colors on this one, just go through this real quick. Here, gotta connect that to that, that to that, that to that, that to that. So that's 4. Then we gotta connect this one to all of them. So 1, 2, 3. After a while, you should probably see that there's a pattern here. This one we have to connect to the other 2. So 1, 2. And then we still gotta connect this one to this one. So that's 1 more. So that's 10. Number 16. Number 16 says, determine whether the following statements always, sometimes, or never true. Explain your answer. Number 16, 3 points, determine a plane. Well, if I take 3 points at random here, it's going to be sometimes, and the reason for that is you could have these 3 points, then yes, they determine a plane. Then you could have these 3 points, where they all fall in a line, so they're all collinear. And then those 3 points don't just make up one plane. There's several planes that could contain that one line. So if the 3 points are non-collinear, like these, then yes, they determine a plane. If the 3 points are collinear, then they could make up more than one plane. Number 17. Number 17 says points G and H are in the same plane. So apparently we have a point G here, point H here. Those 2 are in the same plane. They're both on my whiteboard. And they're in plane X. So if I draw a plane, remember a plane, we usually draw something like that. So they're both in that plane. Any point collinear to G and H is in plane X. Well, if we connected those and made a line, any point that falls anywhere on that line is going to be in plane X. So that's always. Always. So the answer to that one should have been always. 18 says the intersection of 2 planes can be a point. I can't draw this, but if you think about 2 planes, we had a postulate that said any 2 planes, like the floor and the ceiling, must always intersect at a line. So the intersection of 2 planes can never be a point. It's got to be intersection of 2 planes must be a line. I should have put intersection out here. The intersection of 2 planes is a line. Now if you have 3 planes, if you think about the 2 walls and the floor, those 3 planes could intersect at a point. they could come together at one little corner. So 3 planes could intersect at a point. 2 planes must intersect at a line. Number 19 says points S, T, and U determine 3 lines. So if I put points S, T, and U, they're saying that together they make 3 lines. Well, that might be true if I draw it like this, because there's 1 line, 2 lines that they make together, and then 3 lines if I could hit the points. The bad thing with that is if I put S, T, and U like this, then those 3 points only make up 1 line together. So the answer to this one would be sometimes. They make up 3 lines if they're 3 non-collinear points. Like we had here, these were non-collinear, but if they happen to be 3 collinear points, then they only make 1 line. Next. Twenty-two says use the figure at the right with plane J and plane K. State the postulate or theorem that can show each statement is true. 22 says C and D are collinear. Well, I don't even have to look at the picture. If you got point C and point D, they're always going to be collinear because 2 points, and this is my saying the postulate. You could read the postulate off the previous page. 2 points always make a line. So any 2 points are always going to be collinear because any 2 points in the world make a line. 23, line XB lies in plane K. Well, if we look at that, plane K is the blue plane, X is in the blue plane, B is in the blue plane. B is actually in both planes, but it's in the blue plane also. So if X and B are in plane K, then the line that connects X and B must be in plane K. And our theorem for that was, actually our postulate, if 2 points are in a plane, then the line connecting them is in the same plane. So if 2 points are in a plane, then the line connecting them must be in the same plane. 24 says points A, C, and X are coplanar. Points A, C, and X are 3 non-collinear points. Well, if you have 3 non-collinear points, then those 3 points always have to make a plane. So the postulate said any 3 points, and again, this is my interpretation of it, not what the postulate actually says. You could look back a page, see what the postulate actually says. Any 3 points make a plane, and that's actually incorrect. It should say any 3 non-collinear points. Any 3 points that aren't on the same line make a plane. Twenty-five says line AD lies in plane J. Well, we look, plane J is the yellow plane, A is in the yellow plane, D is in the yellow plane. So the postulate that tells us that is if 2 points, we wrote this one down already on the other slide, are in a plane, that's ugly, then the line connecting them are in the same plane. So if the 2 points are in plane J, then the line that connects them, that whole line has to be in plane J. 26, X and Y are collinear. Again, 2 points, the postulate tells us this. Any 2 points in the world, I don't even have to look at the picture. Any 2 points make a line. Any 2 points always make a line. 27, points X, Y, and points Y, D, and C are coplanar. I look at the picture, Y is in the blue plane, D is in the yellow plane, C is in both planes, but again, since they're non-collinear points, we know that any three, I forgot it again, any three non-collinear points make a plane. Any three non-collinear points make a plane. Number 28. 28, you had to write a paragraph proof. In your paragraph proof, and if I read through the problem there, it says point C is midpoint of segment AB and B is the midpoint of segment CD. Prove that AC is congruent to segment AC is congruent to segment BD. You're going to start off your paragraph proof with your opening statement or your thesis statement, some of you called it, like for English class. And then this one, what we want is, we want to prove segment AC, segment AC is congruent to segment BD. Next thing we're going to put, and this I'm just going to write out here to the side, we need our given information. That's the next thing. It's like the body of our thing. So they tell us we were told C is the midpoint of segment AB and B is the midpoint of segment CD. So that's our given information. That's what we were told. From that, you don't always have to have this, but this time we want it. I'm actually going to draw a diagram. Again, I'm just writing this out here. It doesn't have to be part of your paragraph proof. If C is the midpoint of segment AB, then I'm going to draw this. We got segment AB. And I'm going to put C in the middle here somewhere. We know that C is the midpoint. Then they tell us that B is the midpoint of segment CD. Well, that means I'm just going to extend this segment out. And we're going to put a D out here. And we know that B here is in the middle of that segment. So that tells us these two have to, this segment and this segment are congruent. That tells us these two segments have to be congruent. And that's what I'm going to say next. From this, we know segment AC is congruent to segment CB, and segment CB is congruent to segment BD. And the way we know that, you always got to give a reason. You can't just say we know that that's true. I'm going to say because a midpoint, divides a segment into two congruent segments. And I should have wrote out congruent probably, but we'll go with that. Then I'm going to write this since segment AC is congruent to segment CB and segment CB is congruent to segment BD, we can say all three segments are congruent. So we know this segment's congruent to this one, and segment CB here is congruent to this one. Well, that means that all three of them have to be congruent. We can say all three segments are congruent. So what we're trying to prove was segment AC is congruent to segment BD. So segment AC is congruent to segment BD because, and this is a property you learned last year, of the transitive property. Transitive property from algebra last year, hopefully maybe you remember, transitive property said this: if A equals B and B equals C, then you can tell that A must equal C. That's a transitive property from algebra, and that would be your paragraph proof. .34, the last one. They give us this, and they want you to simplify it. The first thing you're going to have to do to simplify it is get rid of the parentheses. Main thing here when you're getting rid of the parentheses, if you have a minus in front of that second set of parentheses, that means you got to do the opposite or change the sign of everything inside there. The first set of parentheses, nothing's going to change. So it's just going to be 8x to the fourth minus 2x squared plus 3x minus 5. That all stayed the same. Here we're going to take the opposite of each thing. That 2x to the fourth was positive, so now it's going to become negative. The x to the third was positive, now it's going to become negative. The 3x was positive, now it's going to become negative. The 5 was a negative, now it's going to become a positive 5. Then we go back through and we collect like terms. Remember, to be like terms has to have the same variable to the same exponent. So this is a 8x to the fourth. It's a like term with the 2x to the fourth. So it's 8x to the fourth minus 2x to the fourth, which gives us 6x to the fourth. So that takes care of those two. Then we look through here. The next highest exponent that we have is the x to the third. Well, there are no other like terms with it, so we're just going to write it down. It doesn't have any pairs to be matched with. So we just write it down, it stays exactly the same. We get rid of it. Then we look through here, the next highest one is the x squared. Again, it doesn't have any like terms, so we just write down 2x squared. The 3x is the next highest variable, or next highest exponent. So it's a like term with the negative 3x. Well, they just cancel each other out. And the next one, sorry. Just seeing if I wrote the problem down wrong. Yeah, I wrote the problem down wrong. This should be a minus right here. Or I'm sorry, that should be a plus right there. That's going to make this a minus. So then we got a minus 5 and a minus 5. That gives us minus 10. That won't simplify any farther. And remember, when you write it, it should be in descending order according to the exponents. So 4, 3, 2, then no exponent. So that's in descending order. And if we look at our answers there, that's answer A. All right, these are your notes. What we're going to cover today is be able to use properties of algebra to write formal proofs. A formal proof, unlike an informal proof, we talked about informal proofs last time. Those were paragraph proofs. A formal proof is also called a two-column proof. And we're going to get to that here in just a second. So use properties of algebra to write formal proofs. The properties. These are the properties of algebra that you covered last year. Some of them maybe you covered, some of them maybe you didn't. The reflexive property, this is maybe a new one that you didn't talk about a whole lot in algebra last year, but we're going to talk about it a lot this year. The reflexive property says that A equals A. In geometry, we're going to say anything equals itself. Anything always equals itself. Sort of common sense. Symmetric property. The symmetric property used a lot in algebra last year, but you probably didn't know it. Symmetric property just says if A equals B, then B has to equal A. And you used it a lot in algebra last year because you might end up with an answer that looked like this. 5 equals X, and when you wrote down your answer, you probably turned it around and said X equals 5 and wrote your answer that way. So all the symmetric property does is turn the two things around. Transitive property we talked about in the homework thing there. If you watched it, transitive property says if A equals B and B equals C, then A has to equal C. To use transitive property, sort of like the law of syllogism, those two things right there have to be the same things. A equals B, B equals C, then we know A has to equal C. The addition property of equality. Addition property of equality. Notice it says equality in here. The addition property just says if you add the same thing, notice on this part right here, I added C to both sides of the equal sign. And if I do that, that doesn't change anything. So that just tells us if we're doing a problem, x minus 3 equals 5, we add 3 to both sides, you still end up with an equation that's true. So you can add the same thing to both sides of the equality. That's why it's called addition property of equality. Subtraction property says the same thing. You can subtract, and I'm sorry that this is on two separate lines, it shouldn't be that way. You can subtract the same thing from both sides of the equation, and it's going to still be a true equation. Multiplication, we multiply both sides by C, same thing. Multiplication property of equality. You multiply both sides by something, and you still get a true equation. Division property, you probably a lot in algebra last year you did this. You had 2x equals 6. Well, then you divide both sides by 2. You're using the division property of equality there. Those 2's cancel out, and you end up with x equals 3. Use division property of equality. Hopefully you remember some of those. Again, the reflexive property might be a little new. Symmetric property you probably didn't know you were using. Transitive property, probably just might not remember the name of it. And then the other properties you used whenever you were solving equations all the way through algebra last year. Substitution properties. The substitution property of equality. Substitution property of equality just says if A equals B, then anywhere you see A, so Anywhere you see that, let me get my pen out. Anywhere you see A, you can replace it with B. So if I have something like 7AB, I can take out this A right here, and I can make that 7 times B times B. You just take out the A and stick B in its place. That's substitution property. Anytime you take out one thing and stick something else in its place. We use substitution property a lot, even though you never knew it. Whenever you're doing something like collecting like terms, or whenever you're just doing something like this, 5 plus 3, and you wrote down your answer is 8, you were using substitution property. You knew that wherever you seen 5 plus 3, you could take it out and stick 8 in its place. That's substitution property. Distributive property, hopefully you remember, everybody usually remembers distributive property. You got a number or letter outside the parentheses and things inside the parentheses. Then you just distribute that out, and that's using distributive property. Now, one thing you got to remember with distributive property, if I gave you a problem like this, 3 times 5 minus 1. Do not use distributive property on that. Because what you should do on a problem like this is go ahead and do the subtraction in there and get 3 times 4, then do the multiplication. You only use distributive property when you have something like 7 outside, then an x plus 3 or something inside, where you can't actually add or subtract those things inside the parentheses. Anytime you're just doing addition, subtraction, multiplication, division, or you're just collecting like terms, what you're going to call this is the substitution property. So anytime you're taking out something and putting something else in its place because you did 6 divided by 2, and you put 3 in its place, you're actually using the substitution property. All right, a 2-column proof. A 2-column proof is also called a formal proof. Remember, a paragraph proof was called an informal proof. A 2-column proof is called a formal proof. And a 2-column proof looks like this. It's going to have 2 columns. The first column is going to be your statements. And the second column is always going to be your reasons. And you're going to number these statements and reasons. So you have statement 1, well, it goes along with reason 1. Statement 2 goes along with reason 2. And you need to number each one of those columns so that you can tell which one matches up to which one. So that's a 2-column proof and what it looks like. And again, in geometry, we call that a formal proof. It looks more like an outline, and a paragraph proof looks like more like a finished thing for English class. Right, I'm going to do these examples. Just follow along, write them down so you have these examples there in your notes. This is our given information. Let's go back. And normally it'll say this, and I just didn't write it down. This is our given information, what we're told there, and then what we're trying to prove, it'll have it this way in the book, is x equals some number, whatever x happens to equal in these cases where we're doing these algebra 2-column proofs. So the first thing I'm going to do on this, normally in geometry we would have a picture, a diagram, and we would really go through and think it through before we started writing our 2-column proof, but when we're doing these algebra proofs, we can just sort of jump right into doing it. The way you're going to write this 2-column proof, your first statement is going to be your given information. Well, this time our given information is 5x plus 3x minus 2 equals 7x plus 8. And how did we know that? What's our reason for knowing that? It was given to us, and that's what we write over here. That's one of them that everybody always likes because everybody can get the given information correct on these 2-column proofs. Next step. You don't actually show your work in the 2-column proof, so down through here, you don't actually show your work, you just go from step to the next step. So our next step would be to collect these like terms right here, the 5x and the 3x. Well, those together give us 8x. So I'm just going to write down 8x minus 2 equals 7x plus 8. And the reason I put for that, substitution property. Make sure if you're abbreviating these, I don't mind if you abbreviate these properties, but don't abbreviate substitution SUB, because if you abbreviate it SUB, then I might think it means subtraction. I won't know the difference. Next thing I would do to solve this problem is I got to get all the x's on one side. So I'm going to subtract 7x on both sides. When I do that, it leaves me with 1x over here. Still got the minus 2 on the left side. And on the other side, the 7x is gone because you moved it to the left, and you just left with 8. Our reason for that is the subtraction property, and I'm going to abbreviate a little bit, subtraction property of equality. Subtraction property of equality, because I subtracted 7x on both sides of the equal sign. Next thing I would do on this one to solve it is I would add the 2 to both sides. So that's going to leave me with 1x equals, add 2 to 8, and you get 10. And what I used there was the addition property of equality. I added the same thing to both sides of the equal sign to get 1x equals 10. Now, most of you probably know that you could stop right there. That tells you that x is equal to 10 and you're done. I'm going to go ahead and put another step on this. If there was another number besides 1 right here with the x, our next step would be to divide both sides by that number. So in this case, we're dividing both sides by 1, and you end up with just x equals 10. And there we used the division property of equality. That's your 2-column proof, and that's what the half sheet quiz that you're supposed to be doing, that you got to turn into the sub before you leave, that's what you're going to do on it. On that half sheet quiz or on any test or quiz that we do, each one of these statements and each one of these reasons count as a point. So this problem right here would be worth 10 points. Next one. Draw my 2 columns, and I don't mind if you do this. You got your statements and you got your reasons, so sometimes I'll just put S and R to make it a little shorter. Our first statement again is going to be the equation. And how did we know that that equation was true? Because it was given to us. That should be an easy one. Next thing, to solve this equation, first thing we're going to do is distributive property, get rid of the parentheses. So I'm just going to write it down what we get once we use distributive property. 3 times 2x is 6x. 3 times -5 is -15. Still got the plus 12, and that all equals 48. How did we know that we could go from this step to that step, or that statement? Because we can use distributive property. distributive property. Third statement. Next thing we're going to do is collect like terms on this side. The 6x is going to stay the same. We got a negative 15 and a positive 12. That's going to leave us with a negative 3. That still equals 48. And there all we used was substitution property. Substitution property. We knew that negative 15 and a positive 12 gave us negative 3, so we took out these two things and substituted in negative 3 in its place to make it shorter. Next thing. Next step, we got to move this 3 over to the other side. That's going to leave us with 6x equals 51. So we added 3 to both sides of the equation. Well, then we used the addition property of equality. Addition property of equality. On this one, when we got the negative 15 and the 12, you could have just put subtraction. You could have just wrote subtraction there, because you actually use subtraction, but we don't want to get it confused with the subtraction property. If you put subtraction property, that means something completely different than just regular subtraction. So don't get those two confused. Next one, number 5. So here we had 6x equals 51. Now our next step is to divide both sides by 6. So I end up with x equals, 6 will go into 51. Let's see, 6 times 8 is 48. So that leaves us with 3 left over. So 6 will go into 51, 8, and 3 6 times, or 8 and 1/2 times. Looking back through here, make sure I didn't do any of my math wrong. That was a negative 15, 6, that's a 12. Another thing I should say in this step up here, please remember that 3, you don't multiply that 3 times that 12, because that 12 is not inside the parentheses in that first step. So that looks right, and what we did there was we divided both sides of the equation by the same thing, so we used the division property of equality. Division property of equality. All right, if you look at page 98, problem number 31. Page 98, problem number 31. They give you a picture. They give you a picture, it looks like this, and anytime you're doing a geometrical one, you need to draw out the pictures on your paper so that you can mark them and stuff. So we got a picture, it looks like this, that's X. You got C here, got B here, got Y here. Some of the classes I said the other day, if you don't draw your pictures, then you ask me for help, I probably won't help you. You gotta make sure you draw the pictures and be ready to show me that you're ready to label things and do things. Measure of angle ACB, that's this angle, is equal to the measure of angle ABC, which is this angle. So we know that these two angles are equal to each other, congruent to each other. And we're trying to write a 2-column proof to show that this angle is congruent to that angle. Statements, reasons. What do I know about these two angles? I know that together they have to make 180. And then on these two angles, I know that together they have to make 180. Well, if that's the case, then angle ACB, and notice I'm thinking this out, angle ACB plus angle XCA, let me make sure I'm naming these right so that they match up to the stuff that we have there. XCA has to equal 180. And then I also know that angle ABY plus, and I should have measures in front of all these, plus the measure of angle, I'm sorry, that's wrong angle. This should be angle ABC. The measure of angle ABY, those two together should equal 180. Well, if we know that this equals 180 and this equals 180, then we can sort of get rid of the 180s and we can say that the measure of angle ACB and plus the measure of angle XCA should equal the measure of angle, that's a measure, of angle ABC plus the measure of angle ABY. Sorry, I got a little close to the edge here. Then the given information was the fact that this angle and this angle were the same. Well, that's angle ACB and angle ABC. Well, if that's the case, if I subtract measure of angle ABC on both, or ACB on both sides, those two are just going to cancel each other out because they're the same thing. Well, if that's the case, then what am I left with there? I'm left with the fact that the measure of angle XCA has to equal the measure of angle ABY. And I think that's what they wanted us to prove. Actually, this angle, they, instead of naming it angle ABY, I should have been naming it YBA all the way down through there. It's the same angle, just a different way to name it. So when I go to do my two-column proof over here, first thing I'm going to write is measure angle ACB equals measure of angle ABC. Should have left myself more space in my statements column there. And we knew that because it was given to us. Next thing we can say is that angle ACB, and I didn't really say that over here, but I'm going to say it here, angle ACB and angle XCA along with angle ABC and angle YBA are linear pairs. We knew that they were linear pairs because if two angles make a straight angle, so together they make a straight angle, then they are linear pairs. So if those two angles together make a straight angle, then they're linear pairs. Step 3, we know that angle AC, and I should be using measure there, measure of angle ACB plus the measure of angle XCA CA equals 180 degrees. And I know the measure of angle ABC plus the measure of angle YBA equals 180 degrees. And the way I knew that, linear pairs must
Teachers, excuse the interruption. I need Mr. Slam and
to
Ms. Stevens' class during intervention to
180
go to the
degrees.
lecture hall. Thank you.
So linear pairs must add up to 180 degrees. Number 4, once I know all that, see if I can fit this in here. If both these add up to 180, then I know that that whole thing has to equal that whole thing. So the measure of angle ACB plus the measure of angle XCA has to equal the measure of angle, I'm going to do this, I'm going to get rid of this. That must equal, I'm going to draw this on over that way. Let's erase that. Let's see, pointer options, eraser. Like this. So our line comes way out here somewhere for our statements and reasons. Measure of angle ABC plus the measure of angle YBA. Sort of ugly here on my 2-column proof. And the way I knew that was I just used substitution property. Substitution property. And we could use substitution property again and just take out like angle ABC here and substitute in angle ACB because we know they're the same. Or what I'm going to do is just use subtraction property and say, okay, then we know the measure of angle XCA has to equal the measure of angle YBA. And all I did was subtract this from both sides. Well, that and that are equal, so when I subtract them, they just sort of cancel each other out, and I'm left with that. And then I just use subtraction property of equality. I subtracted the same thing. Those two angles were both the same, and I subtract them from the two sides of the equal sign. And that would be our 2-column proof. I know that's sort of ugly, but that's one that I just wanted to go over to show you just real quickly. Alright, your assignment is on page 97. Those problems, again, you got to make sure that you get in, you want to turn into the sub before you leave. You want to turn into the sub, page 92, the half sheet quiz, and the third thing was the quiz from page 91 that we started last time in class but didn't get completely finished with. So those 3 things all have to be turned into the sub before you go.